Good evening.
I'm Manoj Mittal. I welcome you all to this webinar, and it is on very interesting and very emerging topic. The topic is intelligent monitoring of infrastructure assets, which I believe is something like digital intelligent monitoring of infrastructure assets. I hope it will be very interesting, and we have very eminent speakers. Mr. Conrad Basimer he has joined from USA, and Mr. Sudeep Majumdar, he has joined from Mumbai. So we will have two speakers today, and this session will be moderated by Dr. Harshvardhana Subbarao, and Subbarao is CMD of consultancy firm Construma, and he holds a PhD degree from the Imperial College London. He has over 30 years of experience and a number of papers and bridge projects to his credit. He is a vice president of technical committees of IABSE, and he also serves on several committees of IRC, BIS, Highway Research Board of India, and he is also very active in Indian Association of Structural Engineers, and he's also very effective, very good moderator. We are fortunate to have him today as a moderator. I'm sure everybody will enjoy his moderation also. So I think now I will request Dr. Subbarao to take over and start the session. Dr. Subbarao?
I think he has disconnected, sir.
Disconnected?
Yes, sir.
There might be some problem with the net. Yeah.
Okay, so let's wait for some time.
Yeah, I think he will join. These are technical glitches.
So in the meantime, I can tell something about ISTRCT. So basically, Indian Association of Structural Engineers is a leading national level apex body of structural engineers in India. It has members from all over India, and all leading structural engineers are a member of ISTRCT. And we are a very effective and very active organization. And we conduct a lot of webinars, seminars, conferences, and also we do a lot of publications. We also publish a quarterly technical journal called SED, that is Structural Engineering Digest, and also a monthly newsletter. And we are also publishing several code commentaries and guidelines for structural engineers. So we are doing a lot of activities, and we also interact with the government in policy making. So before me, Alok Bhaumik was the president, and Mr. Mahendra Raj was the founder president of this association. After that, Mr. S. Ghosh was the president, and then Mr. Subhash Mehrotra and Mr. Mahesh Tandon were also the president. So it is being led by very eminent structural engineers, and it has grown a lot in the last 21 years so.
Yeah.
So those participants who are not the member of ISTRCT, I would suggest that you should also try to become the member of this association. And membership forms are available on the website, but you have to fulfill all the requirements. You just see your eligibility, and then you can fill the form and submit it, and then it will go through a process, and then you can become the member. Oh, Subbarao is back.
Dr. Subbarao.
Thank you. Sorry, a temporary glitch.
No problem, Subbarao. We have introduced you in your absence, I think.
Thank you.
So now you can take over.
Righto. Friends, it's a pleasure to be here today as your moderator. It's a very important topic that we're going to discuss. It is for many of us something of the future. It is something for many of us, something with which we're already living today. It has to deal with intelligence and assets. Assets are everything you see around you, including the house in which you are, the office in which you are at the moment. All the built environment are physical assets. There are also other types of assets like rolling stock, like forest land, like natural resources. All these are also asset classes. And under the concept of asset management, we find are addressing all these various assets. Today, we're going to be dealing with one class of assets, which are infrastructure. Everything in the built environment that you see is part of infrastructure, whether it's for housing or for transport or for water supply or for a nuclear containment vessel or solar energy or the wind. Everything is an infrastructure-oriented asset that you see in the built environment. So today is that topic, a very timely topic, and we have two of the best speakers today with us in this area, pioneers in the field, and I'm very proud to present to you today Mr. Conrad Bessemer, who is the executive chairman and co-founder of prophecysense LLC, and another company called Octave. He's also the CEO and managing partner of Novatech Inc., which is headquartered in Baltimore and Maryland in the US. Through the introduction of new products and his leadership, Novatech sales have grown fivefold as large as before his ownership role when he got involved. Mr. Conrad's entrepreneurial spirit and business acumen are part of his bloodline, as he's the great nephew of Sir Henry Bessemer, who was responsible for disrupting the notion of steel production. You will all recall when you studied about steel making, you read something called the Bessemer process. That's his genes. That's Conrad's genes. In addition, Conrad serves as chairman of the Political Science Board of Visitors on Penn State University. He also enjoys reading, developing colleagues in his career, and is a wine connoisseur. So that is the introduction of our first speaker. And I'll also take the liberty of introducing our second speaker so that, the second speaker first and the first speaker second again. So the first speaker, of course, will be Mr. Sudeep Mazumdar. He has held several leadership positions in large global organizations such as Piramal Group, L&T, Siemens, Tata Consulting Services, Lloyds Banking, and Cognizant. He worked across 40 countries to deliver large business, IT, and digital transformation programs based in UK, US, and India. Mr. Sudeep has been bestowed with the Best CIO CDO Award for his contributions. He has been author of some renowned technical journals and also a TEDx speaker. Mr. Sudeep is a civil engineering graduate from University of Calcutta, a master's from IIT Mumbai, and leadership program from Ross Business School, University of Michigan, to which I also went, Sudeep, incidentally. I did my master's at Ann Arbor, Michigan. He has done diploma in cyber law from University of Mumbai and was trained by Avram Goldratt Institute, Amsterdam. Sudeep is a patron of Mukti, an NGO for orphans. So these are our two speakers today. And I will first call upon Mr. Conrad to speak for about, 15 minutes, Conrad, that I can give you to make a vision towards innovation in this sector. So go ahead.
Certainly I'll try to keep that to 15 minutes, and you just tell me when you need to yank me off the screen, all right? But I really appreciate being here, and I'm actually honored to be here to talk to all of you, because I consider all of you the real experts in this field, in this industry. And so I obviously you heard a little bit about my background with the Bessemer process. And so I was raised in that sort of environment originally. My parents came over from England after World War II, and all we did was hear about Sir Henry Bessemer and what he did and so forth. And of course, everyone knows about the steel patents and so forth, which were sold to Andrew Carnegie, who started US Steel ultimately and so forth. But he had thousands of other things, other patents, got involved in shipbuilding and first perforated stamp machine and all sorts of things in the Industrial Revolution, which must have been a marvelous time, although now is a different type of revolution going on from a technology point of view. So I find it just as interesting and just as relevant. Here we are, some 150 years later. But like I said before, I really appreciate being here. I consider you all the experts. I am not a structural engineer, so I don't pretend to be an expert in the field, and I look forward to your inputs and your advice along that way. But so part of what I'll talk to you about, obviously, is from a business point of view, but part of it, I also talk to you as an owner of two high rises in Florida. And I'm sure all of you recently, this past summer, heard of what happened on the other coast of Florida, luckily, of a building collapse, tragic collapse. And of course, there are all sorts of investigations and reports going on now. But you can imagine that the concern amongst other occupants and owners of high-rise buildings, which proliferate Florida on coastal areas when water is attacking from above and below sometimes. So as an owner of the building and as president of the board of one of those buildings, I have worked with structural engineers a lot, and I've gotten to know more about that than I ever imagined I would learn because of my personal engagement in that. Never mind my business interests, which include monitoring of many different devices, including our own bodies. So, but in the building situation, what I just want to tell you a story of my experiences there, because I participated in countless structural engineering inspections over the years, and I've walked the building with those structural engineers as we look at columns and we look at potential issues on the building. And I've come to have a deep understanding because most of these buildings are built quite similarly. They have an upper level pool deck. And then usually that pool deck is also the roof of a garage. Also, they're suspending a pool from it at times. And it has columns. Obviously, they're holding that structure up. And all that is attached to a building that goes up, 15 to 25 stories high. And as you read about Surfside, you had this almost domino chain reaction of one collapse that led to a series of other collapses, impacted by deterioration from water, not proper maintenance over the years, and water from below as well, with a fairly high water table in the Miami area. But in doing those structural inspections, I'm always surprised because they are very visual based. They involve some very qualified people, not me, walking around that building, looking at columns, looking at structures, looking for signs of deterioration. And when we finish that and they don't see signs, they smile, they hand me a report, and I'm good for another year. The building is clean. Okay. But it always surprises me because unlike when I go to a doctor and the doctor asks me how I am, because they don't really ask the building how it is. They don't look underneath the skin of that building. And so oftentimes I've engaged in conversation with them and asked them about that. And usually the response is that we only investigate further if we see signs of a problem on the outside. And sometimes they tap the columns, listen for things. And that's their practice. And I started one day, not too long ago, to discuss it with them about other ways of monitoring, not invasively, but what were their ways and so forth. And I was really surprised at some of the reactions, and I'd be interested to see how all of you do that, because I don't pretend to know India that well, although I've been there many times. I don't know all the customs. I certainly, like I said before, I'm not an expert in this. But I do know a lot about monitoring of what goes on inside of a body, of what goes inside a machine and so forth. And I've come to learn a lot about what could go on inside of a building. So, and that, when I think of when I go to a doctor for my yearly physical, and I just had 2 of them, okay? And just certainly when you first come in, they look at the outside, they look at your body, and you're not bleeding. And so it would be great if they just said to me, well, you're not bleeding, you can leave now, okay? I don't have to do anything further. Okay, I don't have to worry about what they're going to possibly find when they poke and prod and test and everything else. But it never stops there, as we all know, especially in the US, where they'll test for everything and send you lots of bills for everything. So they draw blood. They ask for a urine sample. Frequently, they do X-rays, they do MRIs, they do CAT scans, all to find out what's going inside of my body. But the outside looks perfectly fine. And unfortunately, at times, they do find things that go on, that's going on in the inside. Okay, and so that diagnostics has blossomed in the field of medicine. And once again, I'm not a doctor, but I do know about monitoring, and I do know about starting to predict things before they happen or as they're happening, rather than after they're happening, and examining an event forensically. So then I try to talk a little bit more to one of the consulting structural engineers we have on the one building, who actually is the owner of the firm and has many people working for him. And what was interesting to me is that he didn't see the need for the monitoring, okay, because there were no signs of activity. And in fact, in having a couple of drinks, he admitted that to some degree, he was also almost concerned about the competition that it might give the field of structural engineers. So I thought about that a little bit. And then I looked back at medicine. I looked back at medicine 50 years ago, for example. And it was fairly well advanced, but we certainly didn't have the diagnostic tools that we had today. And then I looked at how many doctors there were in the United States in 1975, for example. And I then compared it to the number of doctors we have today. The number of doctors have doubled. So all those diagnostic tools didn't limit their growth in the field. In fact, it attracted more and more people. And one of the reasons it attracted people was the relevance and the fact that some in that process, medicine became a technology, and it attracted young people to it. It attracted instrumentation companies and diagnostic companies that were developing tools to make the medical practice even more. And then I think of watching the old movies where they had doctors at the bedside trying to diagnose you, and we sort of laugh at and scoff at what they did now, the things they used to do to people with leeches to cure you and things like that. But that was the practice of medicine compared to today. And what's really changed in a lot of that, obviously, is education is one thing, but what's really changed the diagnostic side of that. So part of what I see as a vision, and certainly not as an expert, not as all of you are, is the opportunity for yet another field, another group of experts to be aided by diagnostics, so that increasingly their expertise and their area of study becomes even more relevant to society, as we not just try to protect our assets, but we protect our most precious assets, which are all of us and fellow humanity of the type that were impacted hugely and tragically in Miami, or in bridges that suddenly collapse without reason, with loss of life. That relevance will attract, I think, more and more people to this field because it's hugely important. And it's urgently needed, not just on bridges that I know proliferate both of our countries, and increasingly our aging assets, just like our bodies. Unfortunately, every day my wife reminds me I'm an aging asset. And so here I am at my no longer a young and tender age, and I want to live to be 100, and I want my buildings to be 100. Okay, but the only way I'm going to be able to do that and survive that is by proper use of technology and assets. And what Sudeep will talk to you later on about are some of the ways we've started to do that, to bring some of the tools of, and it's early technology in this, and early pioneers that are starting to work on this. But my vision, my prediction, in a few years, this will all be commonplace. This will just be an accepted part of your practices, just like it's an accepted part of the medical practice today. That's just the way we do business, and that over time, I mean, it's just like with a doctor. My doctor sat down and looked at my blood work for the past 5 years. You can see a progression. You can see certain things to happen, and it helps to establish a course of action. To have those sort of same tools over a period of time of a life of a structure would be very valuable, rather than looking at it as a static building or any type of structure, that here are the building drawings and here's what we think is going on now. And that type of progressive work and progressive data, and having artificial intelligence that can screen out the noise of that data and compact it for us, so that we as experts can make intelligent decisions and start to understand progressive failure rather than doing forensic examination. That's what we're about. And I find it so interesting as we dabble in different areas. And structure is obviously a personal interest of mine because I own structures, and I certainly don't want to be in the middle of a collapse. And from a medical point of view, I want to last as long as I can and be relevant. Okay, so that's my story, and I appreciate all the group of experts here. It's just like when I talk to my doctor, and I sit with groups of doctors and I talk about it. They're the experts. I'm certainly not. I'm just trying to probe, to help develop areas that I think are capable of being developed, so that we can make humankind a safer place and better place. So I think I sort of feel like we're standing on the end of the ship. We're sailing towards, in this case, America for the first time, and I see the future of what this can be, and I'm hoping that all of you can now see perhaps that future with me as well. And I look forward to your inputs. Thank you so much.
Thank you, Conrad. Thank you for that wonderful allegory you drew between the evolving issues of the health of the human being over the last maybe 2 centuries till today, and that as you related to structures and the built environment. That's a wonderful allegory you drew, coming up with the importance of diagnostics and how it changed the path of medical understanding throughout humankind till now. But the important point that you raised, which I think Sudeep is definitely going to draw down on and utilize in his arguments now, is that data has made all this a very real thing. The handling of big data and an intelligent way in which to look at data and pick up trends and patterns in those data, utilize them to our advantage, rather than go and do tests again and again. We get trends that we will see and which we will utilize to make decisions like a doctor would normally do. And mind you, the structural engineer is not necessarily a doctor, and nor is the person who makes the diagnostic tools a structural engineer or a doctor in that sense. They are maybe technicians, they are mechanical engineers, electrical engineers, they're from different walks, but all put together can only then deal with what is at large. That's the health of our infrastructure and an ability to predict how it will go and to preserve it for future posterity. That's the message you gave us from the wonderful allegory, again, that I really like. Sudeep, your say. Go ahead, Sudeep.
Yeah, thank you very much for mute. And thank you, Conrad, setting the tone absolutely fine. We call ourselves, we are the radiologists of the bridges. We call ourselves, many meeting I talk about it, because what we try to look through the structure rather than looking at the corrosion or the spalling of concrete, but we try to look at what's there beneath, right? Thank you very much, Conrad. Once again, I just set the tone. Just while we are talking about it, in fact, now we have got a few polls, actually 6 questions are there. I'll try to make it as relevant as possible. I know I've got a deadline at 7 o'clock, but I have to push these 6 polls. To start with, you have to possibly, take that yes, no, whatever it is closed-ended question. So since we talked about here that diagnostics, we are talking about predictive. So predictive maintenance of our body and predictive maintenance of our structure. So my first question, Vikas, can you just pull that up, which is, which maintenance method is technically easier, less disruptive, and cost-effective, more cost-effective actually, for structural maintenance over its life cycle? So can you just get there? I mean, what are the options for you?
Do we answer?
Yes, please. Just click on that. We'd like to see that result on the top itself. Yeah, let's stop. So what's the answer? I mean, it's a...
The poll.
So, yeah. So that's it. 95% people believe that predictive maintenance is in the work, right? I mean, it's cost effective, less disruptive. The disruption can be social, political, economic, and also it is technically easier. When the bridge is falling, that's not the right time. When the bridge is having developed the crack, possibly at that time we should do the diagnostics. So let me start my presentation with that. I'm getting, what I'm going to say is, now I'll just talk about it a little bit more. Sorry, just 1 second. What's happening here?
It will take a minute. So the screen is starting. It takes a minute.
Something going on. Yeah, there's something going on. Yeah. So basically,
you want to try again, Sudeep?
Yeah, I'll do.
Yeah.
I think there's some problem there. Can you see me now?
Yes, very clear.
Okay, I would say you don't have to see me the presentation. Yeah, right. So prophecysense are a company. We are Baltimore based, and we have got a 100% Indian subsidiary as well in Calcutta. 2 large brands that we have. One is the Machine Sense and the Signagard. Machine Sense is all about machine and machine tech. We do have some patents there as well. And in Signagard, which is basically our infrastructure and safety tech. So these are the 2 areas we work with. And we call ourselves an IP plus IQ company, basically a technology company. So we develop technology, we embed it in our products and services, and we try to apply that in the new areas, emerging areas. This is one of them. So this is a management team. Conrad is our chairman. Myself as CEO. We have got a CTO who is Dr. Biplab. Biplab is actually from IIT Kharagpur, physics postgraduate, and then a PhD in physics itself. And then Agni, he's joined recently. Agni is our delivery director based out of Calcutta. He's also, we have the same batch actually from his IIT Kharagpur 92, and then I'm Calcutta 94. And we've got a project advisor, Pinak. Pinak is an ex-McKinsey partner. He's actually specifically advising us on the advanced analytics side, because he is actually, Pinak and I worked together, and then we have a common cause. The common cause is deliver this area with a completely new ways, with new ideas and new technology. So we've got a bunch of very good technologists plus subject matter experts. 2 of them particularly I have written here. One is Dr. Prabjyoti. He has done a PhD from IIT Roorkee. He's basically a data scientist, a predictive maintenance expert. And we've got Dr. Animesh, who is from NIT Durgapur. He's also a PhD. He has worked on the structural health area. So this is the kind of team that we are developing, and we would like to develop more and more, because we believe that we can change this particular world. Not only this, and there are some other areas as well. I'm not talking about too much on that. Let's look at some of the infrastructure failure. And this is the I mean, Conrad has already set the tone. Yeah.
Sudeep,
Yes,
your
please.
screen, you'll have to start. Are you showing slides at the moment?
Oh, you're not seeing it?
No. If you've been going with no slides are being screened, we can only see you.
There is some problem. No.
Share screen again, please.
I am doing
You first exit. First you stop sharing, then again.
Yeah, it's coming. It's coming.
No, there's some problem. There's something. So basically I was talking
There
about
you are.
this.
Yeah,
I
here
was
you are. Okay, go ahead.
I was talking about this team, and then I just came here, which is basically, let's look at some of the failure. I will not show much, I mean, too long, but it's important that this is a Surfside failure in Miami. So if I just run this, you can see that how the failure was as a structural engineer. He said that's one column, then the next, the building. This is taken from next building camera, right? Vanished. And this is, we believe, is a structural failure, and the structural monitoring case could have been done possibly a little more intelligently, right? Now, next I go to this is a failure, which is a bridge failure. Some of you have already seen it, but I must show it to you.
When a 460-foot long arch bridge crashed down in a coastal fishing village. An oil tanker truck to fall.
Yeah, so I showed it to you because there is a term actually they used in the whole video, that windstorm. So that means we need to look at the wind, how the wind is actually weather a structure, whether it's a bridge, whether it's a building. So that's what it's very interesting. It's not only that we call this loading pattern. I'll come back to this topic, but I'm just trying to connect the dot here itself, right? It's the wind which made the failure. And the other one is basically some other weathering, as Conrad was talking about. The Miami sea level actually risen over the last 40 years by a meter, right? So there are weathering not because of load and different kinds of loads. This is a Genoa bridge. It's very disturbing. "43 people died in that particular." So it is not a phenomenon of, okay, let me just go through this one very quickly, and then.
Grainy surveillance video inside the tunnel show the frantic efforts to save those trapped. Japanese police say these large concrete ceiling panels, as many as 150, came crashing down, sparked a fire on this major highway connecting Tokyo to central Japan. Witnesses describe a scene of chaos as people ran to safety. Flames and smoke billowing through the 3-mile-long tunnel. One truck driver trapped under the rubble called for help, but there was so much smoke, firefighters had to halt rescue efforts, fearing another collapse.
Yeah. So, I wanted to talk about it because it is not about building, it is not about roads, it is not about bridges, different kinds. It is about tunnels, it is about underground structure, everything. So that is why we are talking about infrastructure monitoring. Now then, after that, I'll be talking about the intelligent part of it. Now, it is not about, again, it is not Italy, it is not Miami. It's happening everywhere, like Kolkata, Mumbai, Miami, Delhi, wherever you can think of, Tokyo, right? So we need to look at it. What is it and what we can do? Now, before I get to the next section, which is how it is evolving in terms of infrastructure monitoring and intelligence, the digital, sorry for there's a mistake in the spelling. So if I look at it, there are some loads, there are some winds, there are some other things, right? Different kinds of, maybe the seismic side of it. There are different kinds of forces, different kind of weathering agent. They're actually forcing these kind of failures, right? Now, my second question to you all, Vikas, can you just pull that up? That I can distinguish from your point of view, I can distinguish the effect of dynamic load loading pattern, which is basically, let's say a 20-ton truck is going at 40 kilometer speed or 70 kilometer speed, or a 90 kilometers rainstorm is coming in, and how it is impacting a bridge or know that. Do I know that? Yes or no? How it is impacting the structures. Bridge is basically, again, it's just one structure, but it can be on any other. Just 10 seconds and we'll take it off. Let's stop. What's the answer? We are saying yes. This is an interesting one. So we know that, we are saying that we know that what is the load and loading pattern, how it is impacting the bridge. I'll come back to you on this. Whoever is said yes and whoever is said no. Both are right, both are wrong, but we'll have to talk about a little bit what we mean when we say that load and loading pattern, how it is impacting, right? The next part is, so we call the generation 1, generation 2, and generation 3 of structural monitoring. The first generation, if you look at it, is most visual. In fact, today also happening a lot of things visually. Then came the generation 2, where we have seen that lots of people actually using sensors, some kind of sensors. Some are asking for, give me accelerometer. Somebody is saying they give me deflectometer. Somebody is saying, give me total station-based monitoring, some piezometer, something. So it's there. Some kind of sensor technology is there. And for some time, actually. We are saying there's a generation 3, which is basically making it to a digital era based on the technologies that already given, applied, and also some newer technologies in this space. So if I look at these 3 areas, and if you look at the way we are doing in different kinds of structures, let me just give one example right now. I've been to yesterday one of the and we were talking about what's going on during the construction, what will be happening post-construction. And I was told that after the commissioning, it will be only for 6 months that we will be looking at what kind of vibration it is. Only 6 months at this point. So there is nothing after that. Right? And I know many bridges are there where there is no drawing even today. So unfortunately, those are all actually being done possibly manually. And even if we actually going, I've got some few more questions for you all. So we'll come back to that. So what we are talking about is we have technology. So put some technology in the buildings, in the bridges, in the tunnels, in the underground structures, get the data out of it. Yeah, whether it's all kinds of technology put together, the sensors, the data hub, data logger, different people are calling different things, and you can actually kind of take enormous amount of data about the structures. But the question is, what do you do with those data? Now, before I go into this, I'll just talk about a little bit on the tunnel side as well, because in the tunneling, it's a new subject actually in India, I'm told, because I'm part of I co-chair the National Committee for Digitalization for ASSOCHAM for tunneling and underground construction. And we're looking at some kind of work here. And when I'm doing some research as a part of that, clearly some of the countries have done something. As I said yesterday, the underground construction, I didn't say anything. And today I'm showing it to you what they are doing. They're actually gone ahead with a very precise and technologies actually sensoring arrangement, right, at different cross sections of the tunnel, and they're taking the data 24/7, looking at the displacement, the deflections, the displacement of the tunnel walls. And I'm just giving that example because we don't have it, or at least so far now, but you can see that the people are already doing it. This is the second tunnel. You can see that this is from China. What they are doing, across the board, they're all putting fiber optic sensors, right, to monitor the entire tunnel. That's what's happening right at this moment. Now, if I come back to this metro rail subject once again, this is needed. Because see, if you look at the right hand side, the tunnel, actually we need 3-axis deflectometer. Though we are thinking that is a ballastless truck, and below the track we actually put the neoprene, and it will be absorbing all these, just like the bearing of the the bridge. We are assuming at this stage the neoprene is fantastic to absorb entire thing actually, and nothing will be propagated. No vibration will be propagated from the train, from the rakes into the wall or into the base, but actually which may not be correct at this point in time. So this may actually not only go to the wall of that metro rail, actually it can go up to the building which are critical up there, right? The peak particle velocity, this is I think 20-year-old stuff, which is also there. We'll have to do it. 25-year-old stuff, we have to do it. But I think we'll have to look at the propagation of these kind of waves as well, right? Because the overburden on the top of the tunnel at different places, different types, different soils. There is some alluvial soil in Calcutta we see, and in Mumbai I see slate, right? But I really don't know whether we know how the propagation is, and this is the data science job. That's what we believe that we need to know, right? So if I look at, again, a question, the third question on the top of it, which is, Vikas, can you just put that back? Which is, I know the quantitative effect of winds, salinity, relative humidity, or seismic effect, or the load, etc., on the structural health. Yes, no, or partially. Thank you. Can I just get the answers, please? Okay, so answer is partially, answer is yes. So around 80% is partially and yes. That means we are getting the data. The next question is my natural consequence actually of this presentation. What next with the data, right? If you have the data, is fantastic. Now, you saw the Gen 1, Gen 2, and Gen 3. I've got some work that we are doing at this point in time, how we are managing Gen 1, 2, and 3 all put together. Let's look at this. The Gen 1 we said, is a manual. There are photography, there are Word, there are PDF, there are server. I mean, just put that into the PDF, into the file, manual file, and the PDF file, and put in the server, and you keep that, time to time you refer that. Second is there are sensors. There will be, sample geographical, graphical representations, and that will be virtually available also, because that will be in server and somebody can look at that document from somewhere else also. So that is also happening. It's not that that's not happening. That's happening in a limited space. But if you look at the third generation, where we are talking about 3D VR technology, because why we are saying that the photography is replaced by 3D VR? Because when something is happening at the site, you have a photograph, somebody has taken it 6 months back, 10 months back, whenever it is. But you still are looking at a two-dimensional photography. We are saying that there is a technology today. The cost is not that much. You can actually 3D VR technology, which you can actually look at a VR gear. You can see it as if you're in the, you're in the site, or at least you can see it on the laptop or the desktop by rotating it. You can do it by yourself, and every 6 months it can change. That's number one. Number two is the drones. Drones with camera, 3D VR, or the LiDAR camera. You can use it. The sensors we are talking about, that we do have the data. We are talking about the cloud. We are talking about the mobility, so that, wherever you are, you can actually see that what's happening on the sensor side. Advanced data analytics. So what's happening with those data? How do you see some of the changes in the structure? I'll come back to that. This is a specialized topic that we are looking at. Then also we are talking about, the computer vision, image analytics. Think of the Bandra Valley ceiling or the Hooghly Bridge, second Hooghly Bridge. At the top of the pylon, how do you see it? Do you send once in a, would you like to send once in a while the drones, the cameras? Okay, yes. Answer is yes. What do you do with the drones cameras? Somebody told me, a very senior guy told me that, Sudeep, I want to do a drones camera. And I said that, what do you do with the drones camera? Today in the marriage party, people are using drones camera. If I take a photograph, I'll give you a photograph, an MP4 file, and just see it. But is it your objective? Or your objective is, you take the camera photograph, either it's a LiDAR or it's a 3D VR or any kind of, good high-res photograph, and see it in the time-lapsed way. Do some image analytics on the vision computing and see whether the spalling of concrete has happened between T1, T2, T3, or some kind of bolt loosening, or some kind of paint chipping out. So we'll have to understand that. So we'll have to use the technology for ourselves. And trust me, no technology is expensive if you use it in bulk, use it in economics and into the scale, right? 24/7 continuous data when we are talking about, advanced data analytics can only go ahead with huge volume of data, right? We can make a model of a 100-meter span concrete bridge of certain kind of certain specification, and we can possibly model what kind of vibrations will be there under certain load condition. But if we don't have the data, every time we'll be going and we'll be finding out something which will be obviously different, but commonality or some kind of common algorithm for a particular structure, particular type of structure, as the doctors do, actually we can't do it. Similarly, impact of multiple drivers. I'll come back to that, this topic. Progressive and intelligent health understanding. So advanced data analytics, impact of multiple drivers, and progressive health. These are three very, very important topics for us right at this moment, and I'll be talking about it. But before I go, I'll just take it off. I mean, this particular slide deck, I'll show you something. Just one. I'll do a new share of my screen. Give me a sec. Sorry, just give me a second. Yeah. So you can see that there's a portal. Can you see the portal, please? Are you seeing the portal, please?
Yeah, there's a bridge that you're showing, right?
Yeah, there's a
portal.
okay. It's a portal. So what we are simply doing is we are saying that when you do structural health monitoring or you do it intelligently, what you do is get all the data, the visual, the data, the analytics in one place, because it's the asset of the infrastructure, first of all. If the asset of the infrastructure is there, the data is there, it's a government's property, probably most of the cases, especially large infrastructure property. So keep it in one place. Tomorrow it will be required by the government only for the infrastructure data exchange, which we don't have as yet. Probably many countries don't have, right? We don't have 20 most critical bridges, strategically placed 10 tunnels data with the National Disaster Recovery. If you want to do that, how do you start? You'll have to start with placing all the data in one place. That's what we are trying to do here. If you look at, so this is a bridge actually in one of the cities. And what we are saying is, first of all, we are taking the data and we are actually showing a digital twin. I'm moving it around. Digital twin. It is not yet phygital, it's a digital twin, right? Not physical, digital. So what I'm trying to do is, I'm trying to look at where this, let's say this digital twin is telling me where the data is, what the data. This is I'm showing you the stored data. Actually, there's a live data as well. I've stopped it for now. I'll show it to you from the phygital, which will be more exciting. So basically, if you see this data, it will be moving actually one by one. This data actually moves. And so how many times you'll be seeing, you must have done some amount of digitalization, some amount of sensorization actually in the different structures, especially bridges, right? You don't know actually data is coming from where, which sensor, where it is placed, some of the times, not always, and whether it's live or not, right? So this is the proof this is just a proof for us that this data is actually moving. I'll show it to you more. Is some, I think there's a problem in my, okay. So this is one, this is the digital twin. Now, if I go to virtual touring, another important thing, this is nothing but what we are saying is whatever you see, you believe in that. When you believe in that, you believe in that when you see it actually on your screen. This is one of the bridges that we monitor. And this is a 3D VR photography. And actually we can put it in the VR mode, and you can actually put a VR gear and see it as if you'll be standing there, right? Also what we are doing, you see this is a hotspot. So what you don't see, you of course you see it. Somebody takes a camera and take a photograph and put it in the PDF or maybe in your computer. But we are saying that, see it here, where is it? Right? So you can actually do different kinds of arrangement here. You can actually, pinch in, pinch out, zoom in, zoom out. Also, there are some other cameras, meaning we have taken photograph from different stations to take 360-degree view, right? This is actually the live camera. You can see that. So this is, we call it a phygital view. So if I go to that, let's say deflection, is it happening? You see that the data below 602 it is showing, and I think it will be just moving just in 624. See, so look at that, it's moving. That's what exactly I said to you. In the digital view, I stopped it. In the phygital view, which is physical plus digital view, you can see that the data is coming. And this is very important for us, that that where exactly the sensor is located, L by 2, L by 3, wherever it is. And you click on that, you are actually seeing the data coming in. So there's the first part of the believing, and then the data analytics part will be going there. So now, same thing, actually, you can do it in different ways. I'm just showing it to you because it's important for us to work in this. And this is a drone visor which is coming up, which is where the drone's photography, and on the top of it, the 3D VR photography, and on the top of it, image analytics will be working on that, right? And we are already working on that. It is not uploaded here. Sorry. Yeah. And then all the analytics that will be coming up. So you are getting actually a structure. You are getting a data visualization. That visualization you are getting in a digital twin mode. You are getting virtual touring, a phygital view where physical and digital both are matching together or mapping together. You can see both of them together. Then you are getting the inaccessible part, what you don't generally see, right? Because even if you are having an MP4, the file, you will not be going there because somewhere it will be there in somebody's computer. So what we are doing is we are putting it on the cloud, and we're giving an access, have a go. And the last one is the analytics. I'll come back to that because this is the special topic for me, and I'll go to the next chapter with that. So I'll come back. Any questions so far? Any just 1 or 2 questions? Then I'll go to the next question. The quiz question. Vikas, can you just take the number 4 question, please?
I think, yeah. Sudeep, yeah. There was a question or a chat about which sensor was capturing the data.
Okay, there are deflectometers, there are accelerometers, and this is one of the bridges in Calcutta. So I haven't checked that. So yeah, there are different kinds of sensors. So the one you saw that I was taking deflectometer. So deflection. So deflectometer. It could be accelerometer as well, because we can calculate deflections from the accelerometer as well through mathematics, right?
Can I just request all participants to put question answer in the question answer box only, please?
I'll take up
we'll take them at the end.
Right, I'll take that. So this question actually is all about, if you look at, so what I showed to you today is, in my view, when I'm in the digital, I'm a civil engineer, but I'm in the digital space, IT digital space for the last 27 years. But I still believe that seeing is believing. What I showed to you is your infrastructure, your sensors, your data, your locations, your physical view, your phygital view, right? And your analytics as well, because I put that at the back. And you can actually see it on the mobile, you can see it on the laptop or the desktop, right? And tomorrow, if there is a National Data Council, Infrastructure Data Council or Data Exchange, you can actually easily integrate that. It becomes a national asset very, very quickly. And it goes on and on. You don't have to worry about for 5 or 10 years, because a bridge, when it is made for 100 years, 4 generations, as Conrad says, I'll have to make safe for my next to next generation, right? We all have got responsibility. Now with this poll, can I just get the answers? Yeah. Do you know most of the times, where is it? You're saying yes. Do you see it? My next question actually was, I don't know, but I haven't asked that question, but I hope that you're seeing it all as well. Okay, the next question, next part of the presentation, I'll just go back to my presentation. Yeah. So now I'll be getting into the more in the data science part, right? I've got half an hour more. Now, before I go into the data science mode, I know that I'm not an expert. I've been in the IT digital field quite a lot, but I've got real good exposure over the last 6-7 years in the construction sector. And by the way, in fact, I keep saying that, I was SDO irrigation for 5-6 months before I moved on to my MBA. And that tells me that at least I know something about the civil engineering. But it's not about civil engineering here we are talking about. It is very simple. Any physical body, if you keep on putting load on it, regular load, cyclical load, and then random load, physically it must change, and it will go through the change. Any steel ball also, steel is a part of the bearing, so it will go through the changes. Even though it is notoriously homogeneous compared to others, it will go through the change. What will change? Stiffness, the Young's modulus. What about the concrete? It's a heterogeneous body. We believe that it's homogeneous because for the designer's purpose, we take it as kind of a homogeneous. It's a heterogeneous body. I have seen a bridge, same bridge, 2 parts, quarry material coming from 2 or 3 different quarry sources. Same M30 concrete. I can't just give a guarantee that everything is same. I mean, I think somebody can, but I personally feel that it will be different, right? Though a lot of things will be similar, but not everything will be same. So what I'm trying to say that now, it's very interesting. If a steel gets fatigued, what about concrete? What kind of fatigue concrete is having? What fatigue concrete can manifest that we can figure out through data, if not anything else, is the fatigue. What is that fatigue all about? Human body. Conrad made some examples. I said my fatigue is if I sit here, it'll be taking time. When I'm fatigued, it'll be taking time to get up. I'll be feeling a little bit of I'll have to put some extra effort for that. If I'm even more tired or even more fatigued, it'll be even more time it will be taking. And eventually, right now I'm 51, when I go to 61, when I'm going to a little more, possibly my fatigue will be, the life cycle wise, fatigue will be a little more and more and more, unless somebody has got in-session energy like Conrad. Right? So point is, how do we understand that fatigue? We have got the vibration data. We have got accelerometer data. But how do you find out the fatigue? Through a right kind of treatment of the data. That's what we'll be talking about. And if we do that, T1, T2, T3 over a period of time, then it is easy to go to the balanced life prediction. That's what we have talked about. We started with the predictive maintenance. Right? So how we can do that? Because in the T1, if I look at, we do have that next page possibly is there. Yes, absolutely is fine. So it is on the bearing side, but let me talk about in the middle of the girder at the top, if you look at, right? When the loads are there, I'm not talking about the over a period of time it ages. I'm talking about just loads are there, there will be a deflection. If there is a deflection, it should go back if the bridge is good. It should go back in time. Whatever the designer says or whatever the construction was done. Everything is good. They have done a stellar job. But actually, during the operations, it's a different world altogether. Global warming is reality. Look at the Miami sea level up by 1 meter. I'll show you some of the data, startling data that we found, and I'll explain that to you. So if you look at it, just going back, so the fatigue will actually set in over a period of time. Now that time is important. It could be 10 years, it could be 20 years, it could be 30 years, but that needs data, continuous data. There's a nice question actually somebody asked me, and I must answer that question here. I'll take the question myself and answer that. Somebody told me that, Sudeep, you're not giving sensors which are battery operated. Somebody is giving battery operated sensor to 3 years or 4 years, their value is, their life is. And I asked the question, very senior guy, I asked the question to him saying that, sir, if your mobile phone, which has got a battery too, if you keep 20 apps on and you just keep it there, will it be, going to the 2 or 3 years that the mobile company says that the battery will be, operative? It will not, because you are processing continuously the app. It cannot be, right? The cycle of charging and discharging, if it is too much, and if you keep on doing that too often, obviously the battery life will be less. So what is it that somebody is doing a magic of 3 years of 3 years of battery life that I can't do it? I tell you the magic. Magic is, ask them what is the data frequency that they're taking. Yesteryears, I know I keep speaking with all you senior gurus of mine. Yesteryears used to take the data once in a month, two in a month, as a quarter, or once a quarter, right? Now these guys are saying that, oh, we are taking the data in 20 minutes, 1 hour. So just think of just a simple, when we are talking about data volume, data velocity, and data variability, important. The variety of data, velocity, variety, and volume, all three important for data science. Think of, this guy is giving you 15 minutes, once in 15 minutes data. That means 900 seconds, one data point. What is the percentage data point that you are getting? How do you know on 13th minute and 29th second, there was not a big dumper which has hit the wall of the bridge? You missed it. And you missed how much damage it has done. So it's basically a continuous data which is needed. I will not overemphasize on that point. Please ask this question, who tells you that we take continuous data, and the definition of continuous data is once in 15 minutes. I'm sorry, sir, that's called discrete data in mathematical sense. Next, look at the other one. Here in this, if you look at this bearing part. Now on the bearing, how do you see the bearing health today? Do you take the bearing out and do an NDT and put it back? No. How do you do it? Of course, there are experts. I know there are gurus who can actually look at it and say, but you have far and few actually of them who can look at it and say that, right? So how do you do when there is no other way to do it? Can data science help? I'm telling you, data science can help. Very simple thing. I mean, I'm saying simple, but it's a data science job. So basically, if you look at this black arrow at the bottom, right? If there are loads, obviously there will be some kind of thrust here. And if the bearing is very good, the bearing will absorb that. Just now we gave an example on neoprene under the track of metro rail, ballastless, right? Now this will give the thrust and this will take. So the kind of vibration that you are seeing here, it will be absorbed in the pier cap. There will be no vibration. In an ideal situation, T0 at the bottom, you see that PS, which is basically VS versus PS versus it's basically, I'm saying that between the two, the correlation factor is 0. That means it is completely absorbed by the bearing. Over a period of time, the relationship between the two, albeit two different axis movement. One is a Z-axis movement, one is possibly Y-axis movement, right? However, there will be a correlation. That correlation we can establish through data science. It will be possibly 0.1, that will be 0.3, sometimes 0.6, 0.7. You can actually take a prediction of what is that time frame, 0.0 to 0.6. Is it 10 years? Is it 20 years? Is it 5 years? So if you take a call that, okay, when there is 0.7, this correlation factor, I will change it. But otherwise, my REX or the cars or the vehicles will be affected, or my peer cap will be affected. It's up to us. I'm doing the radiology. You are the expert. What kind of pills he'll be given, what kind of surgery he'll be doing. So this is where the data science will help. Whenever we talk about structural health, we talk about intelligence, as I showed to you the phygital view. We showed to you, we couldn't show it to you today, but it is there. It's in the next possibly time we interact, we'll be having it, which is a physical damage through computer vision at the top of the Hooghly Bridge or some bridge which is inaccessible. But look at the structural health, the girder health, the deck slab, the truss, the cable, all having different treatment. You can't just have one kind of treatment, one kind of sensor and give it to them, and sensor data will be emanating data, it will be emitting data, and that data will be showing in the time series. That doesn't show anything about the structure. That's what exactly probably in the first lecture Conrad was mentioning that, you don't see through it. You see the data, but what is it, the meaning of it, you don't. Now, if you look at the girder health, simple. You have the vibration data, I just showed it to you, deflection data, strain data. But to be honest, is it really fatigued? I just no idea. Because fatigue, definition of fatigue is, as I said to you, very simple, it's just not coming back. Now, this fatigue can set in by all the right hand side factors, the dynamic load, the load pattern. As I told you, that a 22 tonner 60 kilometers per hour speed and 120 kilometers per hour speed is different. A driver moving it at a certain angle or screeching on the bridge is different, and they're doing it both at the 30 degrees Celsius and 40 degrees Celsius are different, sir. And both are doing it at 30 and 40 degrees Celsius at 20 kilometer and 50 kilometer, which speed different. How do we know that? Hardly. Because we have, look at the right hand side, all temperature, relative humidity, salinity, alkalinity, winds. Winds tore that bridge off in Taiwan. Alkalinity tore another bridge in US in an industrial town. Salinity is a coastal town problem. Relative humidity problem. Temperature, we don't see that. I'll show it to you, some of the things that we have unearthed in one of the bridges. And that bridge, I was told the pH value is actually notoriously in dangerous shape, right? So if I look at all these, how do you know each of them? Number one. Number two is in combination, how it is affecting the fatigue. And that fatigue, how the rate of progression of that fatigue. Who can give this data without a data science? That's what we are saying. This is time that whatever the data we are getting, let's look at differently. Right? Triaxial sensors. And I know that we put some three sensors in different, all 90 degrees, etc., etc. So triaxial sensor is one of the things actually we have patented. And some of the data that you see, we have done some nice analysis on what could be the movement in the XYZ direction. Actually, unfortunately, but again, as a civil engineer, I don't remember that I have read anything on post-construction structure, anything in the book. Civil engineering, possibly 90% or 95% civil engineering stops at the construction stage. It's either pre-design, design, and construction, then stop. It assumes possibly that it goes on and on and on. I'm sorry, it's not really the same actually today. And I'll show you to you some of the data. So it's all about data science. It's all about, predictive maintenance. It's a puzzle that we'll have to solve. And we are out there as a kind of a maverick to solve it. Look at this data point. I showed it to one of the very senior designers whom I, do pranam every day. And I showed it to you. The Z-axis movement, the Z-axis deflection, amplitude, Y-axis and X-axis. This is a bridge. The first question he asked me, Sudeep, is your data correct? I said, sir, I have got only one bridge data here, and this is one bridge data, and not combined 5 bridge data. So one bridge data. So I believe this is correct, number one. When he saw Y-axis deflection, he actually frowned at me and said that, is this data correct? This bridge has a curve. I said, no, there is nothing. Now, I can't answer this question. I can only throw this to the experts, why it could be. Is there anything that a designer can take as an input into his design when he does it? Up to you. This is a reality. Now, when you are saying this amplitude, when many of, I know, I'm sorry, I'm not here competition bashing or anything else, but I see that normally the people take the data and just without treating it, just give it to you. These are time series. You see this deflection. If it is more than these, there will be an alert. There will be 3,000 alerts in a day. I don't know what you do with that data, but and one alert or 3,000 alert, what is the effect of 3,000 alert or 6,000 alert? I don't know. I mean, that is what actually we are saying, that let's look at it from the data science point of view. But that data that you get sometimes is unfiltered, untreated. Look at this raw data. That's raw data actually what you get most of the times. But actually there are ways to filter. And what will you filter? This is not a girder data at the top, the raw data. Actually, this is a combination of girder data deflection. Also a seismic sensor data, if there is any seismic. Unfortunately, this particular piece, there is no seismic monitoring, so we didn't have the data. So that also there is a noise. There is another noise, which most of the people will not do. It is the temperature effect on the sensor itself. It's a metallic part. Even though OEM will say that, my sensor, ultimately the sensors come from China half the time, not half the time, 90% of the time, and globally. And they'll say that, my thing work from Dalian to Sahara Desert, from -60 to +60 degree. And it will give you the some percentage accuracy. I'm telling you, our data says actually none. I mean, this hypothesis is wrong. Right? And when we actually looked at it after netting it, and we see a very different picture. The last part is basically net data that we are looking at. And we saw that which is quite different from the raw data, right? And this is only possible through filtering layer data engineering, we call it data science. And basically there are two parts of it. One is data engineering and data science. Data engineer's job, this one is, how do you make the data clean and meaningful with the business? This is one of the interesting stuff. I talked about those drivers, 7 or 8 drivers. The temperature. So when we look at the temperature and the deflection data at different temperature, how the deflection is, obviously you'll get a scatter diagram. Because this scatter diagram is happening, we have different load and loading conditions, and the loading patterns are there. Different load density, as we called it. Right? When we actually looked at a particular loading pattern and load density, we call this, which is basically load plus the velocity plus some other things put together. We have defined this is called load density. That load density, under certain load density, when we filter, we clearly see there is a huge deflection going up. And how much is that? In fact, this is what, again, 5 times the deflection. I never expected, to be honest. And again, I was asked this question, is the data correct? With my humble answer is basically it is yes, correct. Now, will you take it for the next design? Would you like to take it as a global warming warning signal for civil engineering? It's up to you, sir. But this is a fact. Under the same loading condition, the 10-degree difference on 1st of February to March 20th, there is a huge difference in the temperature. I mean, sorry, the deflection. Same bridge under the same loading density. So there is a difference of deflection for temperature. Now, if you ask me, Sudeep, did you look at the wind and the relative humidity on those days, or did you take those into equation of load density? Answer is no. We did not take it, but that's for the future. Because this load density should be ideally, other than temperature, all 7. In fact, it sometimes gives me pain. Some of the RFPs I respond to, they talk about weather station. Sir, weather station used to be there 30 years ago. Today, one simple API, if you connect to NDTV, connect it to NASA, connect it to National Meteorological Department, that will give you lat-long temperature, lat-long wind speed, 24/7 if you want. Just one API, sir. Maybe 10,000, 20,000 rupees per month. You don't need a weather station today. Let's get the technology evolved. It's if you take my, as a suggestion, recommendation, plead, whatever it is, we don't need it. 7 lakh rupees, not needed, sir. We can take those 7 lakh rupees for 100 bridges, and we can make 100 to 7, possibly 7 crore for the next bridge. Yeah. Last one is, if you look at how we are looking at the progressive debilitation, is what we saw, that we said that, under certain loading condition, loading density, under certain weathering condition, if we look at the deflection of the recovery time, that will give you the fatigue. But important is, it is not a direct deflection versus recovery time. That will not be giving you the exact picture. You have to define that weathering unit, or we have to create that load density and define that load density with 6 or 7 parameters, which starts from load, actual load, the moving load, the speed. Yeah, some more things can be taken into the seismic load, the other weathering conditions. Then only we'll be getting a good, reliable curve. And that curve, if you take year 0, which is, we are propagating this theory that whenever you say that it is to be compared, you have to compare within the virgin condition. What was the vibration condition, the resonance vibration at that time, at the time of commissioning, first 1 year? That becomes your signature, infrastructure signature. That becomes your benchmark. Go on T1, T2, T3, T4, Y1, Y3, Y20, Y40. Sir, compare it against that. That will be telling you a relative position, because there is no other way, sir, to do it. Right? Some of the advanced stuff that we are trying to do, don't go into these pictures. The pictures are fantastic. There's some spectrometry we have just culled out. Our guys have culled out. They gave it to me, but I would say that just look at the top of the, the second line we have shown that the curve that we are trying to get. I said earlier also in other presentations that we are trying to get this residual curve. We are trying to get that, and we'll have to find this alpha, beta, these values, and these will be different for different bridges, and we are trying to get there. And this, another interesting thing, most of the case, not most of the cases, sorry, I'm not exaggerated, I'm sorry for that. So we are seeing that there is no weighbridge, but there is a deflection curve. We are getting a deflection curve. If there is no weighbridge, the deflection curve was the use of the deflection curve, I just don't know. Even if there is a weighbridge at the beginning of the bridge, then you are getting that bridge. Obviously, you are getting a truck. At its truck or a car or a vehicle, whatever it is, you are getting a static load condition. I mean, it's a weight, but it may actually go on the bridge in a different speed. That's what I said, the loading pattern, right? So we don't get that. So for that, you have to get possibly some kind, not possibly, in fact, we are trying to get that with the camera itself. And from the camera, we are getting the validation also, which car it is or which truck it is. And then in some cases, I mean, basically, we are trying to look at, can we, even if there is no camera, can we estimate by looking at the deflection from the reverse side, looking at the resonance itself, and from the spectrometers and density, etc. What was the load? Reverse calculation by looking at the deflection itself. It's a data science work. It's a tough work we are trying to look at, because we are seeing that we'll be possibly getting lots of data where there will not be any validation what kind of load it was. I'll get the data which is deflection. I possibly will also get the recovery, but I'll not get the data load and the loading pattern or something else as well, and more and more things. So how do we get an algorithm ready from the back end? That is also we are looking at. That is where there's lots of work going on the resonance, using resonance. And it is, unfortunately, there is no book can be referred on this at this point in time. So what we are saying, sir, our value is gathering data, not only gathering data which are meaningful with variety, velocity, I said that volume, and the data must give me discoverability. That means that if I get the data photograph, the photograph also tells me that, there's a truck, and that truck is what is a dumper or a truck. And the moment I see that, and if I see the deflection, and if I see the deflection is more or less, I have to discover from the data whether the truck is full or half, or the truck is empty. Discoverability of the data, whether the data from the sensor with the data as a photograph, is very, very important in the PDM, in the predictive maintenance. And it's not easy, but we'll have to try for that. And we are actually working towards that, right? So cloud, mobility, scalability, it's given. We're doing some of the work in different places, but just before I go there, just Vikas, can you just take the 5th question? That intelligent, so currently my technology providers, yeah, can you answer this question? I'm just gathering some of the stuff actually. So as a kind of feedback so that I can use it the next time. Thank you. What's the result, Vikas? Please. Yeah. And that's the future we call. If somebody is showing it to you, fantastic. If it is not, that's the future. That's where we are. Before I finish, I've got one more question actually. Before I go to the question, I'll take the topic first itself. I was talking to one of the insurance companies recently. He told me that, these guys told me that they also do a lot of infrastructure insurance, the bridge, the buildings, the fire, all these things. I asked a question to them that, what do you know about a bridge? They said nothing. They have got civil engineer, no doubt about it. But they said nothing in terms of health condition. They told me in Mumbai, they actually have insured a particular bridge. And I particularly know that that bridge is not in good condition. So I told them, how do you put a premium on that? He said, frankly speaking, there is no authentic mechanism, risk engineering mechanism to put a premium on that. Sir, this is where we are. So data science-based approach not only can transform this intelligent monitoring space of infrastructure, it can transform the way the nation behaves with the data. And we are talking about digital countries, right? And at the same time, this can transform the risk engineering, the way the insurance companies are doing today. And that tells me the last point on this fire. I'm invoking some, or I'm provoking some thoughts into you, that most of the times, today also there is a Hindustan Times report that 70%, a nice journalist reported, 70% of the time, the fire happens because of short circuit. Short circuit, in our view, is the end state. It's like a doctor's certificate of cardiac arrest. It is never the reason. It is the end. The reason is somewhere. It needs digital. It needs artificial intelligence, is data science, and many more things, sophisticated treatment. So building insurance. So if you look at the technology stack we are talking about, it not only can transform the structural engineering space, operative period, also how the fire happens in a building or in a hospital. Remember that there are some 29 fires in India in the last 15 months in the hospitals, 93 people dead, right? Hardly we know why the fire is. And the journalist says that 70%, he knows that it's because of short circuit. I'm sorry, sir, this needs a special treatment. So this is my 7th question for you. Because can you just, before I stop, 7th question. Insurance companies have the data about the girders and the bearing of a bridge or a tunnel, wall vibration or displacement of a tunnel when they insure a structure. Answer yes is no, yes or no. I answered actually, but still I kind of, pushed you to that direction. I'm so sorry about that. Stop it, please, Vikas. The answer is, that's a good question. Some people think that they have, and I'd love to see that actually. And actually, this is where this is the future. So I will just stop here. I think, thank you very much from our team. Frankly, our team knows 100 times more than me, but I'm also learning, and it will not stop very soon as far as this field is concerned. Thank you very much, sir.
Yeah, thank you. Thank you, Sudeep. It has been an amazing presentation, Sudeep. You brought us the whole paradigm of where we actually do not belong at the moment. That paradigm which we need to somehow imbue and understand, that imbibe and accept the fact that with just data, we have nothing. Data just for itself has no meaning, but data used intelligently can mean a hell of a lot, both in predictive science of, say, structural health monitoring, and also for protecting the assets for the future, picking us trends which we don't necessarily have to do a lot of super high diagnostic work, but picking up the trends and using that data intelligently, and the ability that we have with handling big data today is so key. You also spoke about the volume, the attributes, I would say, of data the 4 attributes that you talked about. And the last one, apart from volume and variability, the last one you talked about was discoverability, about how to relate an empty truck or a full truck going across a bridge to the kind of data that you picked up without actually being able to see it in real time, but to have that predictive ability to develop that. The science of algorithms, of course, have developed to such an extent today. The power of computing is so, it's evolving in quantum leaps and bounds. And the fact that you have these lovely sensors, for example, the 3-axis sensor you spoke about, you have so many other, lovely devices and sensors, which you didn't speak in this event here today. On another event, I have heard you speak about them. All that tied together, it gives the whole gamut of structural health monitoring that you portrayed today, for which we're very grateful, to showing us that there is another shift that is required. It's like a paradigm shift really from where we are today and where we need to leapfrog to, the 3rd and 4th and 5th generation of events that are happening in this field. No doubt it's a very fast evolving field, and obsolescence is going to be there. Things are going to get obsolete even in this area with time. But if we don't take a stance today, we may not know how to handle this and how easy it is to actually link it to sort of a touch screen type approach where you touch a screen and the device pops up with its real life signature work that is available for you to assess. And apart from that, you also showed that the data gives us the values that we need to set up thresholds, to understand and filter between noise and temperature and effects of load mixed with temperature, because the structure suffering in fatigue over time will have its signature changing due to so many other events. So we need to understand what the separate causes of those changes to the behavior of the structure are, and that can only be done through data science. It cannot be done anyhow else. So I think this paradigm that you put to us today is really a wake-up call for us. We thank you, and of course, your company, Sensor
Prophecy.
Prophecy Sensorlytics, and the 2 products that you showed us, machines, Sense and the monitors,
SignalGuard,
and SignalGuard, which you spoke about today, partly. So thanks very much. I think I will ask Alok. Alok, if you're there, are you on the screen today? No? Okay. Maybe then take some question and answers from the audience. Conrad, if you want to unmute and say a few words before I take questions. Conrad?
I appreciate the audience and appreciate it. It was, I think, a great conversation. Obviously, I think my story set the example, but Sudeep delivered on what we're actually doing and pioneering in some of these areas. And we'd love to be able to extend a lot of that with your help. I would add that the early part of this was done with the help of local structural engineers and university professors that helped us through that study in Calcutta and put up the first bridges there with retrofitting sensors. I think one of the questions was about retrofitting. So there's ample opportunity to do a lot of retrofitting in the industry. So thank you again. I appreciate the conversation.
Wonderful. Let's take a few questions then, shall we? Sudeep, you have the questions in your question answer box. Do you want to choose which ones you want to answer so that you can build the story about the pattern in which you answer the question?
Very quickly, I'll just give the answer one by one. I mean, but if it's a long one, I'll take it later.
Better. You can tell the story.
Okay, the first one is Ruan Villages. Okay. Gas. Okay, so where this equipment will be installed in the structure, building, or bridge to give exact result? Okay, this is a very interesting question. Actually, a lot of people ask me this, Sudeep, how many? Give me 80 sensors, give me 60 sensors. We say that, sir, this is an engineering problem. If you ask somebody, a designer of a bridge, give me a bridge, what will he ask you? He will not. He'll ask you a lot of other questions, right? I'll also ask another question. What is that bridge made of? Right? What is the span of that bridge? And how is it, whether you want to do a gutter monitoring, you want to do a cable monitoring, there are 2 different things, right? So let's take it as an engineering subject, right? We all are engineers. And yes, girder, somebody does L by 2, somebody does L by 3, somebody does the bearing, somebody, I mean, the girder topic, if it is a girder, if it is a cable, it's a different. So we do differently at different point in time. So that's something that we can take it up case by case. Yeah, it's an engineering solution. Take it that way. Okay. Shashwato is simply praising. I think it's all right.
Go ahead. Go ahead. That's why I said choose.
Thank you, Shashwato. Thank you. So, is it forward problem and inverse problem? I think he's meaning that that's the problem I talked about, that from the back end we are trying to look at what was the load, because if there is no load sensor or a validation discoverability mechanism, how do you get from the, so it could be a reverse problem as well. We are trying to do it an inverse problem. We are trying to treat it as inverse problem because not everywhere we will be able to get the discoverability. It all depends on, if you give me 100 bridges, we'll get it accuracy with possibly, quite 90+%. If you give me 2 bridges, I can't make it 72%, right? So that's how the data science works. Okay. Is there digital equipment work in old structure? It's old, new. As I said, from the day one, we should be looking at it, right? So you may not do it on year 1, 2, 3, 4 every year, but at least for few years to start with, and then possibly take a look at, based on that data, take a look at whether it's needed or not. There are some bridges I know within 10 years they need to do that, within 10 years, and people are thinking about it. Yeah. So next question is Nanda Dulal Dasgupta, astonished to see the progress in this area of structural engineering. Are the regulatory bodies ready to accept this technology? I will give it to Dr. Harsha Subbarao on that. It's not my cup of tea. Yeah.
No, well, at the moment, it's still evolving. We don't have anything quite like this except for what has been done in Calcutta and some of the bridges. You might have more examples in the metro area, and I don't know about the tall buildings. I'm not so sure in the hospitals, but there is definitely a crying need to have this kind of data-enabled assessment and data-enabled predictability, a continuous gathering of data and intelligent use of data. This we don't have at the moment. In fact, tender documents are not so written that they allow for this specifically. It is not like allowing just for normal sensors and a collection of data. It's the whole package that has to be addressed.
Yeah.
That is not there, Sudeep, at the moment. Yes.
Yeah. So next question is he's saying that if there is no drawing or design, how do you do that? See, there are technologies like scan to beam. I used it in my earlier organizations as well. Scan to beam is a technology which can get you an architectural drawing, which is basically a scanner. It could be a LiDAR scanner, it could be a light scanner. Then let me put it this way. These scanners can actually take the photograph and join it together, get you an architectural drawing. So right now we are talking in a Calcutta bridge. That bridge actually doesn't have that. So they are talking about, actually the KMD is talking about that. So you can use that technology. That's a steel bridge, possible. But it's a concrete, you have a difficulty to get the engineering drawing because you can't just get inside. Then you'll have to do a little bit manual job as well. But technologies are there for certain areas, certain areas is evolving. Next is the behavior of structure. This is from Nandadullah. The behavior of structure as being predicted from data collected should also be substantiated by structural theory. Yes, I mean, we are not doing anything against structural theory. In fact, we are doing beyond structural theory, sir. What is the unit of fatigue of a structure? Is there any one fatigue, 2 fatigue? There is none. So that's why I say that it is beyond that. Structural. If I go by structural theory, I'll be dragged. We'll have to look beyond. That is why the technology is all about. That's what Conrad said. 75 to 2000. The doctors have doubled. So has the technology. So here also the same thing. Next,
can I just pause
yeah.
for a moment? This is Jose Kurian, a very, very dear friend and a past president of the Indian Concrete Institute and one of our foremost engineers in the country involved with Signature Bridge. Greetings to him. In fact, in this fora, you have some Dr. Lakshmi, you have Rakesh Chopra from Northern Railway Chair. You have some wonderful people in this audience, a very, very knowledgeable audience indeed. And, right at the forefront of evolving tech, if you like, in this country, research as well as practical, as railway, cable stayed bridge, everything. So Jose Kurian is here and I greet him and I would be proud to read out his questions. Is it not necessary to validate the virgin data from the analytics with the threshold values supplied by the structured design? That is validation, linking and validation. How do we validate the virgin data itself otherwise?
No, good, great question, sir. So you are talking about the base data validation itself, right? Base data validation, which is the benchmark, you are validating the benchmark itself. Maybe then double set of data set you'll have to take. So maybe you have to create a redundant set of, I mean, just off the cuff answering, I'll have to think through it. But if we want to have the base data validated by another set of data, maybe one way of looking at it, obviously design, what are the considerations of design, but even then also there could be a problem, because as I said, design is not is equal to construction, is not is equal to the real world, right? That's our view. And second one is you can have a redundant set of sensors to cross validate between the two. Yep. That's my view, but we can talk about it. But Dr. Hasasubara, Dr. Subara,
go ahead.
You took a name, sir, and whom I pranam karta hu main unko. Rakesh Chopra is there, whom I used to present actually in the L&T TIC board, and every time he used to push me back on this digital. And he also actually taught me quite a few things that railways were doing, and I still go back to him to learn quite a few things.
Yes, in fact, they're both very, very dear friends of my late father, and I'm very proud to be here with them, at this event too. They're very dear friends of his. Let's take the next question.
Yeah. Next question is how to predict fatigue failure. So that's what I said. There is no equation at this point in time. There's a failure, but we can look at the progressive debilitation curve. That's what we are saying. So that is why. So give us, sir, bridges, give us buildings. That is why we'll have to start doing this residual life. Once we have all those drivers data, the digital data, then we can actually figure out this debilitation curve. And that will tell us actually where exactly it is going, right? One is failure means the end point, but nobody will be looking at that end point. Before that itself, they'll be doing a predictive maintenance. That's what our objective is, not to see the failure, but to prevent it. Yeah.
Proactively. Go ahead. You have a few more questions.
I think a couple of questions. So if we have no structural drawing and design, I think I answered that question. And the last one is, are you incorporating system identification technique in a FEM model of the bridge or a building? Finite element FEM, or what is that? Sorry. FEM model. Sorry, I think I'll have to take that up differently. I can't answer this because possibly I'm not understanding fully that question. But we will take that offline, and I can come back to you if you write to us, or you have got the our mail IDs and the numbers as well.
That's Debashish Bandopadhyay. Okay.
Yeah.
There's one question I had, or another thing I would like to put into it, is the need to revalidate your structural analysis over time due to the changing parameters like stiffness and so on, and finding out where you are at the structure at a certain point further along. Maybe fatigue, maybe creep shrinkage. And if you're able to accurately get that information from your sensors and your predictive data assessment, then we can feed back into our FE model that we've set up.
Okay,
and today with parametric FE, parametric FE is so fast, so brutally fast. So parametric FEM linked with this is, I think, a wonderful future to foresee.
Okay.
Any thoughts on that?
Right at this moment, I'm sorry, I can't throw any light, but I can discuss it with our team to understand what could be the appropriate response to that, and we can come back to you.
Wonderful, thanks. If I read the chat box, Conrad, there are excellent, very informative, good information. So there's no point reading that. You can see it yourself. But I'm just trying to see if there are some questions that might be, yes, the YouTube video will be available for all. It will be posted on the ISTRACTI website. Mr. N.R. Jairam, again, someone whom I know well, is this mechanism workable for dams, on dams? How much of this is actually being used for dam technology, technology in dams?
So dam is a very large area which is coming up. I know that in the dam, some company is working. some basic things they're working. Dam rehabilitation program is a real UN sponsored program. I know, in fact, last week itself, I was visiting in Calcutta actually, because I was in irrigation. That's why I can talk about. So irrigations, I was talking to my friends who are superintending, and they're saying that, it's an area to look into. And there were some work, I would say, that we are learning also from that, what they have done. And the technologies are today, the GIS technologies or the drones or the other technologies are there, and which can do a wonderful job for dam as well, apart from the seismic and normal sensor, that vibration, etc. I think, see, we are talking about all these sensors getting the data. So ultimately, what are the dam's point or the points of failures or points of concerns that if we get, I mean, we can make the meaning of the data, meaning out of the data, we can do. And we are looking into it very actively, by the way. So beyond that, I can't say much on this, but maybe 1 month down the road, if somebody contacts us, he'll be seeing a complete, quite a bit of informed view around it, please.
Wonderful. Okay, we don't have any other questions unless you see something, Sudeep, that you want to specifically answer, something that might have come up. How do you estimate the force and cables of existing cable stay bridges without damaging the cables and structures? You want to have a
very quickly on that is basically what we are trying to do is we are trying to import a technology from US. So if you look at the cable, so many cable structures are there, and the cable, what is the cable condition? Let's say, now what are the cable condition? One is the cable tension. That's one. Second one is cable, whether the cable is mechanically damaged or not, like the strains are damaged or not. Number two. Number three, the inside the lube which is there inside the cable, they're damaged or not. Number four is the P cover that is damaged or not. Now, just think of the Bandravali ceiling, which I keep talking to Pramod Bungirwa. Just think of that, the length of that cable. What you do have today is possibly at the drum, what is that cable tension? But actually you don't know. So there are technologies which is actually highly patented at this point in time. We are trying to have a dialogue with them, which is basically spider robot. They are actually putting through the cable. It is going up there, and they're actually sending magnetic waves, and from the other side it is taking the magnetic flux and actually looking at whether the strains are cut or not somewhere, right? Exactly where it is cut, how many are cut, right? So artificial niches they're looking at. Third one is the lube condition. Plus there are cameras as well, which are actually looking at the P condition, I mean the polythene, the coating condition as well. So, and across this, so I think we are at the level 1 of technology at this moment. Already in US there are technologies, and in fact we are trying to bring in that way, right? One is tension, of course, but tension is less or more, whatever it is, because of the strains are damaged mechanically, right? How do you know that? That part is we are trying to get the technology.
Righto. We don't have any more questions, Sudeep, Conrad. We don't have any other questions that are there. But any comments you want to add, Sudeep, Conrad, and then we can ask, anybody in the audience want to unmute and say a few words? We can ask the Korean sub to say a few words, Chopra sub, if they're there still, to say a few words. So if you have anything to say, go ahead. Otherwise, can I ask for them to be unmuted to say a few words?
No, please. I would like to hear from you.
Wonderful. Vikas, are you online, Vikas? Can you unmute from your side as host?
Yes, sir.
Joe's Korean. First, Joe's Korean. Thank you.
Yes, sir.
And ask him to unmute. Korean sub, you have to unmute. Wonderful. Go ahead, sir.
Good afternoon to everybody. I don't know, but Sudeep, you remember we had a very, very exciting workshop.
Yes.
I was moderating your presentations, wonderful presentation at that time. It was quite interesting, and we have drawn a lot of material from you, and we are trying to use them in our standard making. It's a very nice time we had.
Yes.
And Harsha, it's nice to see you once more in the saddle. And I'm very happy to know that Rakesh is there. He's my batchmate. And we had a nice time together in the training as well as through the career. I don't know whether he's around, then I would like to see his face right now. But I'm extremely happy to listen to you, Sudeep, the way the civil engineering and structural engineering is growing. I'm very sure that this also should become the part of our academic studies, because post-construction, what do we do with the structures? We are in the dark. So one of the ways is to get the trail through the service life of the structure. And even if you want to extend the service life, this kind of data is required. And I'm very sure what you said is that it is the data which is being created has to be analyzed and supplied to you in a useful format, and in a very simple format, so that even some of the triggering values, of course, you can, it should not be too high or too intimidating, so that we can design the whole system right when the construction starts. So that is the future. That is what we have to do. You have to design right in the beginning what exactly you want to extract, and then implement them during construction, some of the senses, or after construction, many of them which can be redone. So this has to become the part of the design process. So as structural engineers, this also will be one of the responsibility, and I'm very sure next time we write the TOR for detailed design, this aspect also should be included. So it was nice meeting you again, Sudeep. I'm very happy that you could come and present it, and thank you, Konrad. It was a very, very, very encouraging way that we are brought into this scene. Thank you very much. Thank you, both of you. And thank Harsha.
Thank you,
IASC. Thank Alok for organizing many such wonderful sessions. Thank you very much.
Thank you, sir. If I can ask Rakesh Chopra Sahab, if he's there, can he be unmuted to say a few words? Vikas?
Yes, sir.
Can you unmute Rakesh Chopra?
Sir, Rakesh Chopra is not listed in the
His name came up, so it might have
sir.
left. Okay. And what about Dr. Lakshmi? She's still there?
Lakshmi
Parmeshwaran, then you can unmute her. She was there earlier.
No, sir.
She might have also left. Okay, I see. Okay, righto. Thank you then. It's my pleasant duty to say thanks to both Konrad and to Sudeep on behalf of ISTructE. I hope this is just the start of a partnership of knowledge and sharing ideas and your wisdom, Konrad, and Sudeep, your intense knowledge and devotion to, you seem to have sort of a missionary zeal, which I really, is very infectious. So I do hope you take this really ahead. Whatever we can do as an institution, we're there. We see the need. And yes, this is just the start. I think we've got a long way to go. You have some case studies, which next time we will do a case studies, the ones that you've done in India. Let's look at those as a case study presentation and draw from that the next time, more on the case study side as a next follow-up presentation. Konrad, thanks for being with us. It's probably an early morning. I'm not sure what time it is there, but
it's almost 10 o'clock. So certainly I was long out of bed. You didn't have to get me.
Well, I didn't have to get you out of bed, but now I think the evening is drawing on and we all deserve a drink.
Yes.
In India.
I wish I could join you. But
a time will come. A time will come.
And don't forget that Konrad is a wine connoisseur.
I heard that. Yes. So no. Okay. On that note, then we'll have a Pinot Noir of some sort. Something at least of that sort should be available.
Yeah.
Right. I thank all the participants for being with us. This is the way we grow and we share together. And those of you who are not members of the ISTructE, I entreat you to join. It's a wonderful body, and we share all our knowledge. As you can see, the YouTube video will be available to all participants. And Vikas, I'm not sure if you are going to give a participant's a certificate.
Say, yes, sir. It will be. Yes, issued on request basis only.
Okay, so those who want a participant certificate, if you just email, we will make one and send it to you for sure. That's my closing remarks. Thank you all for being with us, and have a pleasant evening, those in India and those who have joined us from elsewhere in the world, from Singapore, from Africa. And I do see names from different countries for sure, definitely not Indian names, but names from all different countries. So I thank them for joining us and be with us again the next event. Thank you all, and good day. Good day.
Thank you. Thank you. Thank you.